Solving a system of equations by graphing. Graph both equations on the same graph and estimate the simultaneous solution. So I'm going to look at both of my equations and notice that each of the equations is in slope-intercept form. So I'll start by graphing the first one, y equals 1/2 x. With that equation, I notice that my slope is 1/2 and my y-intercept is actually 0. So I'll start by plotting the y-intercept at 0. And I'm going to use my slope to get to the next point on the line. So slope being 1/2 means we would go up 1 and right 2 from our y-intercept. So up 1 and right 2. That will leave us with our next point on the line. And we can keep going if we need to. Up 1 and right 2 again to get the next point. And the next point. So I want to connect my points as accurately as I can so that when I graph the other equation, I'll get an accurate solution. So let me try my best. Usually I'll have a straight edge. So that is the graph of y equals 1/2 x. I'll now move to my second equation. Y equals negative 2x minus 5. And with this one, my slope is negative 2. And my y-intercept is negative 5. So I'll begin by plotting the y-intercept at negative 5, 0, negative 5. So 1, 2, 3, 4, 5. It's about right here. And I notice with my slope, it is an integer. So to help me understand where I should be moving, I like to always put my integers over 1. So that when I read my slope, it's actually telling me now to go down 2 and right 1 to get the next point on the line. So if we do that from our y-intercept, down 2 and right 1, be able to plot our point. And we could do this one more time if we'd like to, down 2 and right 1 to get the next point. And I kind of see the motion my line is making. I know it's going to cross somewhere about right here. If I want to be accurate, if I don't have my straight edge with me, I might use the concept of maybe graphing the slope, keeping in mind that the negative sign can be pushed to the numerator or the denominator. The slope could also be, I'll just write it on the side or right below here. Slope could also be considered 2 over negative 1. So that could give me more indications if I want to continue my line a little bit more accurately. This would tell me to go up 2 from the point and left 1. So from the point I have here, if I go up 2 and left 1, I can get my next point on the line. And from that point, if I go up again, up 2 and left 1, I can kind of see exactly where my line should be crossing. So I have to do this because I don't have a straight edge with me, but I know a lot of you will. So sometimes just graphing the first few points and being accurate when you draw your line will be sufficient. So let me connect my points. And so those are my 2 lines. And what I'm trying to do is estimate the simultaneous solution. So what that means is what point is common to each of the lines. And we can kind of tell where the lines intersect. That will be our simultaneous solution. So sometimes you'll see me point to it, or it's my solution. And besides pointing to your solution, you're going to want to name where exactly the solution is according to your origin. So from there, we will just name our ordered pair, which is -2, comma, -1. So the point -2, comma, -1 is the simultaneous solution to the system of equations we have here.